Okay, hello. This is a video for finding a project submission, term 2, and yeah. So I will basically just walk through the demo and so on. All right. So first I will show run.sh. So the commands. So the command is command, which I also put in my README. Command plus X run.sh. And then we'll run the executable file run.sh, and now it loads the native, the Google All Tools, native libraries, and so on, which takes quite a while. I mean, about like 10 seconds. So just wait about that. Yeah, we'll just wait about. Yeah. So this is the general interface. So how does it work? Very simple. This is also very simply the project, the workflow satisfiability problem here. The whole point of this GUI is to basically insert a WSP instance. So a number of users, a number of steps, some constraints, an authorization matrix. So in this authorization matrix, you'll be able to put which users can do which steps and so on, which steps can be done by which users, and then run one of 4 different algorithms. So this is the number of steps, number of users. Then you have here where you put all the authorization matrix, which I'll go through in a bit. Here is all the unary constraints, or binding of duty and separation of duty constraints. So the 2 different kind of constraints that we're looking at, the user independent constraints. And then in the end, you'll be able to choose from 4 different choices. So this backtracking algorithm is actually an XP algorithm. It's not an FPT algorithm, which is just basically recursively trying out all different possibilities, but it's not fully brute force method, because it does prune some recursive branches if they don't satisfy the constraints. And then we have the workflow satisfiability pattern backtracking problem. That's the main kind of endeavor in this project. And then CSP encoder and SAT encoder are both using the same engine in Google Tools CP, CP-SAT engine. However, since the CP-SAT engine is a hybrid model, they're just using 2 different pseudo formulations for. I'm using 2 different pseudo formulations for to encode them into this engine. However, yeah, I've decided to put both of them to run both of them on the. So yeah, the user can basically be able to choose any of these once the instance is initiated, and then run the algorithm. So let's walk through how it works. So first things first, you can choose, of course, the number of users. Let's say in this case, I'll just choose number of users 4, number of users 2, number of steps 2. And then what you do is you click update, because if you don't update, then this won't carry on, and nothing will happen. WSP is unsatisfiable because there isn't even any instance. So we click update, so we get a pop-up message saying that the 4 users now it's been updated. And now immediately what happens is, now this authorization log is where we will see the authorization matrix. Now automatically, if I just leave it like this, it's nothing's gonna work, because again it's still unsatisfiable, because I automatically put it so that none of the matrix is satisfiable. None of the users can do any steps. So if I actually update the matrix now we have a fully authorized matrix. And so if we were to check whether whether it's satisfiable, now we can see that it's satisfiable. I'll go through in a bit what this actually means. So this is how you can kind of play around with this. So you can for example, pick user 1, all steps, and that will also, and then of course I clicked authorize here, so that means it will stay the same, since they're already all authorized. If I, let's say, now pick unauthorized, now the number of steps are the columns, so the whole row of the user of that particular the steps are the rows, so the whole row of those, the whole basic number of steps for that user have gone, allowed to have been 0. So row user one for step user one for step one and user one for step two. Now let's say okay, and yeah, so what else can you do is, yeah, you can update this continuously, try different things, and this will always log, the matrix will always be logged here on the authorization log. However, if let's say I was to update again, then it would reset. As you can see, it's reside matrix 422, and then I have to again put whatever instance I want to put. Another thing to discuss in this particular panel is that if I have I added these all users, all steps kind of drop down thing, because it just kind of makes it easier. So if we consider a much bigger matrix, maybe a 8x8, and then we then check, and let's say I wanted something, so like I wanted this whole kind of row or something like that, I wouldn't have to every single time for every single step, user one, step two, blah blah blah. It would be way too long. So if you just do all steps, all users, and update, it will just make it very easier, and just basically get rid of this tedious repeated. Yeah. So for the next panel is to basically create the constraints, the user independent constraints. So these are 8 steps, because we have an 8x8, so we will have, and then it's very similar style. You can so this is a pop-up message. If I keep 2 steps, the same step, and I try to make a constraint, which is contradictory, it doesn't make any sense, it will give me an error message, not allowing the code to crash or something. So then I can add some constraints, and yeah, and it's very similar style to the previous panel, and everything is always logged. I can always go back and forth unless I change the number of users and number of steps is instance. So now let's say, okay, so now we have a completely empty matrix. So realistically, we shouldn't have any. It shouldn't work. This shouldn't work. So I mean, the WSP should be unsatisfiable. So if I try to run it, it gives me unsatisfiable, and that would be for every single one of them. However, let's switch it up. Let's actually make it satisfiable, and let's add a few more constraints. I guess 7 and 8. No, actually, do that, and then 8, 3, and 7, and then we go there, and then first we will check the pattern backtracking algorithm. So what does this panel even do? So basically what it does, it generates you all the assignments, and so this assignment, every single index in this, for example, in this vector encoding, will be the step, and the number is the user. So that's how the assignments are generated. Here I also decided to, because again this GUI is for experimenting, I decided to add the block to user matching, since to basically run the Python backtracking algorithm, you have to have many partitions, and then each partition is made up of blocks, and these blocks are usually matched to there's a block to user assignment, which graph, and then the maximum matching algorithm is run on that. And just as the maximum matching algorithm is run, just before running the maximum matching algorithm, this is the graph that this is what you get. So basically, for example, block, this is for this particular block, and user 1, and this will represent a whole equivalence class for those particular type of encodings. And since we didn't put that many constraints, and the authorization matrix is pretty, all of it is once, then of course we will have a huge amount of assignments. Now let's play the backtracking algorithm. Now this XP algorithm, as you see it, as you saw, it took a little bit of time. This is because it's generating every single assignment, and of course it will take much exponential amount of time. So then we can run the SAT, and it will give you just one assignment. That's all it needs to show that it's satisfiable. And the same with the CSP. And that's kind of basically it. I guess I could try something different, maybe a different base case, something that, okay, update one more instance. I'll do step 1 and all users, and actually maybe steps 3 and then 5. And then here we have a matrix. If we were to make the whole row of a step, or whole column, sorry, of a step unauthorized, then of course it's not possible to then have a assignment for such a instance, no matter if you don't put any constraints. And as we can see, that's what happens. If we change that to authorize, and we add a couple constraints, step 3, then add maybe another one here. Step 1 to step 3, step 1 and step 3 already, step 2, step 3. So step 3 and step 2 is the ones that we haven't done. And we run the algorithm. We can see that there is that it's satisfiable. And for the backtracking, it should give us this. For example, in this very case, this would represent the equivalence class for every single assignment that every single one of these assignments. So that particular encoding would represent the whole class of these encodings. And then we can check the SAT encoder and CSP encoder, and then we can part of the GUI is that you can easily go back and forth without much issue, and then you can redo your instance without just applying modifications. It'll only completely reset once you change the number of users and the number of steps. This was my project, and yeah.